All right, guys. So what we're doing today is going over the review sheet, and your test will be tomorrow. So the first one here is going through, use the diagram to answer the questions. We'll go on and go through all of them. Whenever we name a circle, circle dot, and then the center, which here is A. So circle A. Name two radius, or radii is what it should be, which is any line from the center of the circle to a point on the circle. So AD would be 1, or AB, CA or AC would be 1 as well. So there's actually 3 here. Now we could say AD or DA, AB or BA, or CA or AC. Any of those pairs work. Now, naming, if you put down AD and DA, that's still only one radius. You just name the same one twice. Chords connects any 2 points on the circle. So CB. Yep. And EG. Yes. But it doesn't have to go through the center. The diameter does, which would be our CB. Diameter has to go through a center. So the diameter is the longest chord we can have in a circle. It's the biggest one. Secant line intersects the circle at 2 points. So AD intersects the circle at 1 point D. So EG would be a secant line because it goes through the circle at 2 points. Now this one here needs a line because we're talking about a line. Now there's multiple ways we could have named it because we could have said EG, GH, HE, any of those that name that line work. Only 2 letters to name a line. And our tangent intersects the circle at only 1 point. So we can say JI or JH or HI, any one that names that line that's intersecting the circle at 1 point. And the point of tangency is the point at which it intersects it, which is point I, or I. I would be the point of tangency, and JI, HI, IH, JH, any of those that name that line work. Secant line intersects the circle at 2 points. Tangent is 1 point. Any questions on 1 through 6? Seven, 8, internal and external. So it is considered internally tangent if a line intersects both circles at 1 point and crosses the imaginary line between their centers. So this here is internal. And this here would be, it's internal if it goes between them, it's external if it doesn't. So if the line goes between the circles, it's internal. If it doesn't go between them, it is external. That's it. Tell whether AB is tangent. If it is, it means it's going to make a right triangle, so A squared plus B squared is equal to C squared. Which one do we want to look at? 9, 10, 11, or 12? 9, 10, or 11. And then, so you're going to say that 9's a Pythagorean triple? Because, so the hypotenuse is this length here, yes? So is it a multiple of 5? Because if, so 5 divided by 25 is? 20 divided by 5 is? And 15 divided by. So this one is, yes, this is tangent. AB is tangent. Yes. No. Let's see here. Yes. Yes, it is. Because this is the hypotenuse. Yep. Well, the hypotenuse is, by definition, the longest side. Now, this one's not, because if you do just 16 and 36 squared, we would get 65, but 16 is not the whole length. It is 32, because it's the radius was 16, but this triangle setup has 2 radii, not 1. It had the whole diameter. Does that make sense? Any other questions on this one here? No, because here we would do 63 squared plus 32 squared and see if it equaled 65 squared. Now, you could do it one at a time, and when I say one at a time, figure out what 32 squared is, and then figure out what 63 squared is and add those two together. But again, you're plugging both of those in the calculator. Just do it all at once. And see if we get the same thing as 65 squared. No. So this is not tangent. Questions on this here? Questions on 12 through 15? Well, we know that these two lengths are going to be equal. So 6x squared minus 15 is equal to 279. So the first thing we can do is add 15 to both sides. And if we add 15 to both sides, we get that 6x squared is equal to 294. Then I would divide by 6 first. Because we can square root both sides, but we would have to simplify the square root of 6 on this side and divide it. It would be easier to divide it first. Because 4, because 24, 54, 49. And then we would square root both sides. Plus or minus 7. Because whenever we take the square root of both sides, we add the plus or minus, because 7 times 7 is 49. Negative 7 times negative 7, well, the negative and negative make a positive, and then we get 49. Let me check. Now, not on all, they don't all need it. The reason that this one needs it is if we look back at the original problem, what do we have? 6x squared. So if I plugged a negative 7 into the x squared, or times it in by itself would make it back positive. The positive 7 is still positive, so it works, yes? So for this one here, because it's x squared, both are actually technically correct. Because 6 times negative squared minus 15 is going to give us 279. And 6 times 7 squared minus 15 is still going to give us 279. We'll get the same answer either way. There are two that have it, and I will want both. Okay? So if the square is in the start of the problem, we're most likely going to need the plus or minus. We'll come across one later, because if it starts out where neither one has an x squared to begin with, because if we remember our tangent and a secant line, the tangent squared is equal to the exterior times the whole, we don't need that plus or minus. Most likely, yes. So for these here, for these types like this here, where they're just set equal to each other and solve, if there's a square, we're going to need the plus or minus. if you're not sure, go on and add the plus or minus, and then check both, like we did here. Because if you type this into the calculator and this in the calculator, and one of them doesn't give you back to what it should equal here, 279, or both sides aren't the same when we plug that value back in, then we know that doesn't work. Does that make sense? Okay. Any other questions on 12 through 15? Are we good with these here, setting them equal to each other and solving? Questions on 16 through 21? Any questions on how we solve these here? Well, we know that this here is 90 because all of these should add up to be 360. So any of these here, it's just finding their values. DCB, no, EDB. So I'll just do EDB. EDB. These three here, if we add them together, we get what? 130. So EDB is 130 degrees, and this would be minor, because less than 180 is minor, greater than 180 is major, and if it's exactly 180 degrees, it's a semicircle. Semicircle is exactly 180. And I think the answer key says 140. It's supposed to be 130. Because 59 and 39, 51 and 39, 0 carry the 1, 5, 6, 7, 8, 9, plus 40 is 130. EDB should be 130. That was a typo on my part. Any other questions on these here? Do we kind of like these? Be careful on these because it's happened in years past. Because each one of these, exactly like on the test, it's going to want the measure and type. Because MBA is the measure of arc BA. So we want the measure in degrees and telling if it's major, minor, or semicircle. Exactly 180. I believe, grab this here. Yep. Nope, we're not going to worry about these if the arcs are congruent. Yeah. So not worrying about, find the indicated measure. Okay. So EF would be what? 104. Because since these two circles are congruent, this chord's congruent to this chord, so AD has to be the same as EF. AB and DC are 6, so it's just saying that these two are congruent. AEB is 120. So this one down here is, yep. So, questions on 28 or 29? We can look at 29. So, if two chords intersect and one of them's the diameter and they make a right angle, it means that these two arcs are congruent and these two are as well. So we can say y minus 5 is equal to, or y is 45. We're going to add 5 to both sides. to get the value of y. But we can also say that 4x minus 36 is equal to 2x plus 24. Those are going to be equal. But we can add 36 to both sides, telling us 4x is equal to 2x plus x is equal to. So y is 45, x is 30. That's it. Questions on these here? Question on anything we've done so far? Okay. We'll come back to these to remind me to come back to these. Yeah. They're kind of hard, more tedious, more steps than they are difficulty-wise. Now, 32, why don't we look at it? So ABC is 164. What do we know about angle D? It is, because it's congruent if it was a central angle. This is an inscribed angle, so it's going to be half. So we can take 164 and divide it by 2, which is 37 times its vertex is on the circle. It's a central angle. They're going to be the same as its arc if its vertex is on the center. Questions on this here? Now we know the opposite angles in a quadrilateral are supplementary. They add together to be 180. Do we want to look at 36, 37, 38, or 39? Well, we know that these two angles add up to be 180. So 4x plus 74 is equal to 180, yes. Well, we can subtract 74 from both sides, telling us 4x is equal to 106. Then we can telling us x is equal to 2. 26 is because 2, 26, 6 and 6 is 12, 12 and 12 is 24. 2, I believe it should be 26.5. And we get this here. Now the other one is equal to 180. So we can subtract 102 from both sides, telling us 3y equals 78. That's nice. $26. That's it. Because the opposite angles in a quadrilateral, in an inscribed quadrilateral, add together to be 180. Mm-hmm. Yes. If it's 4 times 26.5 plus 74 will give us 180. Well, so 4x is an inscribed angle, yes? And it's connected to the diameter. So this arc is what? So 4x is half of, what is half of 180? So we're saying 4x is equal to divide by 4, divide by 4, 22.5, yes? What do we know about any three angles in a triangle? They add up to be 180, yes? Well, we know one of them's 90. So 2y plus 90 plus 42 is equal to 180. 2y plus 132 is 180. Subtract 132 from both sides. 2y is equal to 48. Divide both sides by 2. Yes. And that's the same for the next one. X should be 30, y should be 36. Well, the acute angles of a right triangle add together to be 90. So 90 minus 54 would give us 36. We know the 3x should be 90, so 90 divided by 3 is 30. Questions on any of this here? Questions on 40 or 41? AD, here is 75. So the other arc, these should add together to be 360. That'd be 5, 10, so 5. 15 would be 8, so 285. Well, the measure of angle 1 and angle 2 are half the measure of their arc. So for this here, we're going to take 75 and divide it by 2. So the measure of angle 2 is 37.5. 8. Well, then we can take 285 and divide it by 2. 142.5. Well, 1 and 2 make a straight line, don't they? So they would add together to be. So once I found angle 2, I could subtract it from 180 and get 142.5. As any two angles that make a straight line add up to be 180. And the only way this works is actually if that line is tangent to the circle. It only intersects it at one point. So it has to be a straight line. Any other questions on 40 or 41? Angle 1 is 49. So angle 2 has to be, because they add up to be 180. To get AB, we multiply 49 by 2. And we can multiply 131 by 2. Well, 98 plus 262 is 260. Questions on this here? We can look at both of these here. Now, when two secant lines intersect outside the circle, that exterior angle is equal to half of the bigger arc. Which one's bigger? Yes. Minus the smaller. Now, again, when we minus the smaller, there's two terms there, yes? So that means we're subtracting the x and subtracting the 6. Well, 3x minus x is 2x, yes? Negative 2 minus 6. Negative 8. We need to be careful with that, because if you just put minus x plus 6, you would get the wrong answer. Because that negative is not applying just to the x, it's also applying to the 6. So putting those parentheses around it is helpful whenever we're subtracting the smaller. Well, just remembering to apply the negative to both. Now, can we take half of 2x and half of 8? Can we multiply 2 by both of those and get nice numbers? Yeah, we can go on and do that. So 34 is equal to 1/2 times 2x is just going to give us 1/2 times 8 is -4. If we have odd numbers, numbers that don't divide by 2 well, we can just multiply both sides by 2 and still get to the same answer. X is 38. Whenever the lines intersect inside the circle, we add them together. Similar formula, but instead of subtracting, we add. And the angle is always kind of connecting one of the two that we have. So y connects to both of those there. Now on this side here, 1/2 times 73 plus 111. Is there a single variable anywhere there? Plug it in. Because I could do it by hand. Because that'd be half of 184, 92. Well, we still need to find x, yes? What do x and y do? Make a straight line. Any two angles that make a straight line add up to b? Yep, 180 minus 92. 88. Questions on any of these here? So for 42, so 36, what was it? 38 plus 6 is 44. Yeah. Because 38 plus 6 is 44. 38 times 3 minus 2 is what? So what we're saying is that 34 is equal to half of 104 minus 44. Now 104 minus 44 is, let's see here, make sure, 38 times 3. Let me just make sure, 38 minus 2. It's 38, isn't it? Yep, 38 times 3 minus 2 should give us 112. So 112 here. And if we subtract these, minus 44 is 68. Half of 68 is 34. So it does work. So these here aren't going to have an exact proportion to them, but when they plug into the formula, they'll still work. Any other questions on this here? So they told us this is 49, yes? ACB. So did you figure? Do you know how? Understand how we got AB? Multiply that by 2, yes? Which would be an entire circle is 5, 2, because that's gone, is 5, 15. which would be well, you understand how we got 131. Does those two angles make A? Minus 49 is? Well, to get the arc, it's twice that angle, yes? 131 times 2 is? Any one of those two ways you can go and still get the same answer. Does that make sense? Okay. Any questions on 44 or 45? What do we know about a whole circle? So 240 minus 360 is? So here y is 120. Now, is equal to half of the bigger minus the smaller. Bigger is farther away. So 240 minus 120, yes? Well, 1/2 of 240 minus 120, that's all numbers on that side, yes? So at this point, we could type that entire side into the calculator and get an answer for that half. But if we did it by hand, 240 minus 120 is 120. Half of 120 is, so at this point here, we can add 10 to both sides, telling us 6x is equal to 70. Divide both sides by 6. 1, 10. 6 repeating. 11.6 repeating, or 11 2/3. Or 4/6. Either one works. Any other questions on this one here? Questions on 45? Huh? No, because since we don't know what the other part of this is, it's kind of hard to say, but it might be, because I don't know the answers off the top of my head. Because to figure this one out, we would do 48 is equal to half of the bigger minus the smaller. Now on this one here, can I take half of x easily? Well, no, it's just going to be half x, yes? So what we can do here is, instead of taking half of x, I can multiply both sides by 2. Because 2 times 1/2 is 1. 2 times 48 is 96 is equal to x minus 60. Add 60 to both sides, which tells us x is and that's it. Any other questions on these two here? X is what? X and y make a straight line, don't they? Any two angles that make a straight line add up to B, 180. Does it even matter what we do with the other sides? No, we already found x, we already found y, we're done. What do we know about a central angle and its arc? They're congruent, so y is 120 and x are going to add together to be 180. Because this four-sided figure does add up to be 360, but 180 and 190 and 90 is 360 minus 180 is 180, yes? So these two here have to add up to be 180. So x plus 120 is yep, that worked out coincidentally, but it doesn't always work out to be that way. Let's look at 48, because whenever we have two lines intersect at the center, this length times this length, so 6 times x minus 1 is going to equal 4 times x plus 3, the product of these two here. So 6 times x is 6x. 6 times negative 1 would be negative 6. 4 times x is 4 times 3 is 12. We can add 6 to both sides, which will tell us that 6x is equal to 4x plus 18. Then we can minus 4x, telling us 2x is equal to 18. Divide both sides by 2, telling us x is equal to 9. Any questions on this here? No. Same thing as what we just did. Any questions on 49? If we're just multiplying those two segments together, here x times x would be x squared. X times 1 is going to be plus x. Negative 2 times x is negative 2x. And negative 2 times 1 is negative 2. Here, x times x would give us x squared. X times negative 2 is negative 2x. Negative 4 times x is negative 4x. And negative 4 times negative 2 is plus 8. Now, if we can get some of this down, we would have x squared minus x minus 2 is equal to x squared minus 6x plus 8. Because the only like terms we can combine are our terms with just x, because they're the only ones that have something in common. Now, the first thing we can do here is subtract x squared from both sides. And this is kind of nice for us because, well, both of these cancel out, both of these cancel out, telling us negative x minus 2 is equal to negative 6x plus 8. Next thing we can do is add 6x to both sides. Negative x plus 6x is 5x minus 2 is equal to 8. Then we can add 2 to both sides, telling us 5x is equal to 10. And last but not least, we can divide both sides by 5, telling us x is equal to 2. Yep. Questions on this here? $50 or $51? So this one here, it's exterior times the whole. So 30 times 30 plus x. Exterior length times the whole is equal to the exterior length times the whole. So this one here, we can distribute the 30. 30 times 30 is 900. 30 times x is 30x. Right, and then multiply by 27. 27 parentheses 27 plus 23. Or we can just type it in the calculator. We couldn't type the other side in because it had a variable. But 27 times 27 plus 23, all numbers. Plug it in. Yes. Which will tell us that 30x is equal to 450. Yes? And then we would and get 9. No, yeah, 15. And that's it. Even on the one before, it's still exterior times the whole. So 7 times x plus 1 plus 7. Any questions on this here?